So, let's switch back to the primes finder. And I'm going to say more efficient primes finder. Okay. Number equals 2. Well, number less than 100. Mumble, mumble. Okay. And then number plus equals 1. With a little bit of thought, you can convince yourself that I don't have to test to see whether 4 divides into a number to find out if it's prime. I only have to test to see whether 2 divides in. Every number is either prime or the product of a bunch of primes. So when I'm checking to see if you're prime, I only need to test to divide you by all the primes I've found so far. Right? Because if 10 divides into you evenly, then 2 and 5 must also divide into you evenly. They're your prime factors. 10 is 2 times 5. If 12 divides into you, then 3 and 4 must divide into you, and 4 is just 2 times 2. So 3 and 2 must divide into you, and so forth. Okay? So if I keep track of the primes I've found so far, instead of just printing them out and throwing them away, I can reduce the amount of work this program has to do. Now, my program's even more complicated than the version that only checked up to square root. So I don't throw the old one away. I certainly don't start overwriting it. Start a new file. Make sure that I've got the old one until I'm convinced this one is correct. And even then, I don't throw the old one away. I'll see tomorrow morning what I should do with it instead. Okay? But I always keep the old versions that I believe were correct so that I've got oracles to compare more recent versions to. That's the only practical way to test anything with complicated output. So I'm going to say if is prime and primes dot append the number. Whoops, what's that? Well, primes starts off as an empty list. Okay. So as I'm going through my loop, if the number I'm testing right now is a prime, I'm going to add it to the end of that list primes. Primes, append this to yourself. It's called a method. Okay. And most things in Python have methods. It's a function. It's something that knows how to do. That knows how to append things to itself. Okay. It's got other methods like sort and reverse that do the obvious things. If I go to a list and say sort yourself, it goes, okay, I'm sorted. Reverse, it reverses its elements. Append, it adds one to the end. So if its length was 5, its length is now 6, and that's the extra value that's been tacked on the end. Most things in Python are expressed as, hey you, go and do this. In a language like C, you mostly write functions. You've got a function and you say, append to list of primes and number. Well, if that's a list, it knows how to append things to itself. So I just ask it to do that. That's object-oriented programming. Congratulations, you now know how to do object-oriented programming. We're done, pretty much. We'll come back and look at that in more detail later. Really what I'm saying is you know how to do that, so please do that. And here's the thing I want you to do it with. If you are a linguist, subject, verb, object. All right? Fred kicks the ball. Primes appends the number. Okay? And what's the mumble, mumble, mumble? Well, for divisor in primes, if number remainder divisor equals 0, is prime equals false. And I have to initialize is prime to true. So, this is exactly the same as the loop I had a moment ago, except instead of saying while divisor is less than my number, and let's try everything, even the things that aren't worth trying, I'm saying That is a list of the prime numbers I found so far. So let's just try each one of those. So that is looping over the values that are in there. Let's have a look at what happens. When number is 2, primes is the empty list. There's nothing in it. It's a bag, but the bag is empty. Very disappointing Halloween for that child. So, is prime is true. Divisor and primes, there's nothing in there. So the loop doesn't execute. It's like saying, well, number greater than 0, but number starts as -5. First time we do the test, we're done. So that never executes. So down here, is prime is true. So now we add 2 to the back of primes. Primes is now the list containing 2. Oh, and we print it out. Go around again. Same thing for 3. Is prime is true. Now we say for divisor and primes. Well, primes is a list. It has one number, the value 2. So we check to see if 3 divides evenly by 2. It doesn't. There's nothing else there. So now we've got the list 2, 3. Okay? Come around again and try number equals 4. Is prime is true. For divisor and primes. Well, the first divisor is 2. 4 does divide evenly by 2. So we said is prime to false. Come around again, we try 3. Doesn't work, but it doesn't matter. We already know it's not prime, so we don't do this. So we come out of this and we haven't printed the number and we haven't added it to that list of primes. So let me add a little bit to this and we can trace that execute. Let's just see if we can find the primes up to 10. Okay? Yep, divisor is a variable. Divisor is a variable like any other. The for loop is assigning values to divisor over and over again. As soon as I use a variable as the target in a for loop, what I'm telling Python is, get things out of here one at a time and assign them to divisor. It's exactly as if I had said, divisor is assigned primes of 0, do this. Divisor is assigned primes at 1, do this. Divisor is assigned primes at 2, and do this. But Python is taking care of the assignment. That's just a variable like any other. There's nothing magical about it. The for loop is going to pull the values out of that one by one and assign them to divisor on my behalf. Are you okay with that?
Yeah.
Okay. Okay. Let me print out a little bit of stuff. Okay. That might help. So, print trying number. Okay. And then down here, I will say, well, I'm going to print number out, comma, is prime. Print primes is now primes. Okay, so let's just